In this module, we're going to discuss some of the interesting feeding behavior aspects of dairy cattle. A lot of this research comes from Michigan State that we'll be reviewing here in the module today. When we look at feeding behavior, what would be the primary goals we'd like to achieve? Well, they don't change very much. We'd like to have behavior that would maximize feed intake on these cows. Secondly, we would like to have a feeding behavior that would maximize nutrient digestibility and in some cases fermentability. And certainly, thirdly, try to optimize rumen fermentation and microbial growth to optimize end products for the lactating dairy cow. Interesting slide looking at how feeding behavior impacts with intake and all the factors that go into this circle, and just a tremendous array of different activities and receptors and other aspects that will impact how cows consume feed, how much they'll consume. We're not going to walk you around this chart. You may want to come back at some point and look at it again, but you can see there's some environmental factors. If you look on the left-hand side on humidity, temperature, you've got some feed characteristics on the bottom, particle size, palatability, density. You've got some cow aspects looking at competition, social behavior, eating patterns, and then you've got some things that are physiologically important, some of the chemical receptors like pH and VFAs and rumen physical factors as well. So certainly when we talk about intake and function and what factors hit that, a lot of things feed into this feeding behavior profile. This slide, very interesting, shows different factors that can impact total dry matter intake. In this example, we look at three factors: the number of meals, the length of the meal, and then the pounds or rate per minute being consumed. In our example on top, under the normal, we would have 11 meals per day, which is fairly typical, by the way, for a TMR ration. Average duration of 25 minutes and about 1/1600ths of a pound per minute. That would result in about 44 pounds of dry matter intake. If we increase the meal numbers by 2, keeping everything else constant, theoretically we could approach this 50-plus pound dry matter intake. Another way we can approach that 50-plus pound dry matter intake is increase the length of the meal by about 4 or 5 minutes. Now that may have something to do with cow comfort, heat stress. Standing on a rubber mat, for example, would change how long a cow would be willing to stand there at a feed bunk. And the rate per minute. This may do such things as particle size, dustiness, wetness of the ration. Again, by changing that rate by 3/100ths of a pound per minute, we can get up to that magical 50 pounds. So it's a pretty powerful slide that says there's lots of different ways we can attack this, and by optimizing some of these factors, we can get to fairly significant increases in dry matter intake. This is some neat work from Michigan State looking at just differences between cows, and it's dramatic. In this research done up at Michigan State by Mike Allen and Rick Dato, production ranged from 50 to 100 pounds per day. Dry matter ranged from 33 to 61. The number of meals as low as 8 as high as 15.5. The length 20 minutes to 43 minutes. The rate 1/10 of a pound to 2/10 of a pound. So if you're a geneticist, you go wild with this slide because this is look at the variation, and then you as a dairy manager, how can you get kind of to the right side of that slide to try to get the big numbers, because that's going to help maintain production, intake, and body condition score. Another thing they looked at Michigan State, and there's some earlier work from New York as well, showing that cows have different patterns based on age. And so as you look at behavior and feeding systems, you may want to build on this. Notice on first lactation cows, there's really not a difference between that and older cows on the number of meals. They're sitting right around 11. But if you look at the length of the meal, you'll notice that the older cow tends to stay there longer. They will have about an extra 5 minutes. That's about a 20% increase. The rate, you can see older cows eat faster than younger cows, so that's about a 14% differential there. Meal size, again, these older cows tend to eat more dry matter per meal, about a 38% difference here, and total eating time, you can see, is also about 10% longer. So you can begin to see very quickly why on some farms, by having a first lactation group of cows, we're segmenting those cows away so they don't have to compete with cows that eat longer, eat faster, that are more aggressive, and therefore may encourage greater dry matter intake on these younger animals, and that's what the research says. You can expect about 3 to 5 pounds more dry matter intake when heifers are by themselves than when they're mixed in with all the competition. Another question is, when do cows eat? And again, if you look at this Michigan State data set, it says the percent of the total ration. You'll notice there are two rather pretty apparent spikes. You can see the first one, hours after feeding. You can see how that occurs. The big meal, those cows are fed twice a day at basically 1 in 12, and that's where the big spikes occur. And that's why some herds that go to 3-time or 4-time a day milking, they'll get some increased dry matter intakes because you get that third spike or that fourth spike. You'll also notice these cows will come back to the feed bunk at different different times during the day, and certainly that may depend on such things as when farmers push up the feed or feed availability or other physical activity that's going on that may encourage that cow to come back and forth on these various meals. Certainly we have other things that have cow behavior. This slide shows chewing and roughage activity and values associated with it. That's another behavior, is rumination. Cows need to spend about 550, 600 minutes a day of chewing time, both in eating and rumination time. And you can see certainly the physical form of the hay makes a dramatic difference. We can almost cut that in half if we really reduce particle size on hay. On corn silage, again, you can see a pretty dramatic effect if we chop it fine versus coarseness. And of course, here's where the kernel processing starts to come into play, because we can start moving some of these feeds up on the corn silage window up and still have the breakage in the kernel we want. But again, we look at that behavior of chewing time becomes very important for rumen health and performance on the cow. Again, another data set from Michigan State looking at effects on rumen pH and eating time. You can see again, every time the cow consumes feed, you see an increase in pH initially. That's due to the chewing activity. Then you'll see it ratchet on down again depending on how much the cow consumes and how much of fermentable carbohydrate and other nutrients that came into that mix there. And so you see this rather significant change in rumen pH. You can see it going from as a high of about a 6.5, dropping all the way down to 5.5. And of course, here at Illinois, we tend to use the number pH 6 as being indication of acidosis. So you can see if you drew a line across from 6 that there's going to be several periods during this feeding episode that we're going to be below the pH 6, and that will have some effect on rumination. And also, you can see the impact is bulleted at the bottom of the addition of the substrate and the saliva being produced from the cud chewing response. The last thing on behavior we'll discuss in this module talks about meal size. Be careful, this is on kilograms on the bottom, so multiply this by 2.2, but you can see on the left side the change in pH units. You can see that when we're feeding less than a kilo, that means less than 2.2 pounds, the pH change is less than 0.2 of a unit. So if the pH was a 6.2 in the rumen, we'd expect it to drop it down to about a 6. But you can see a very nice relationship in this data set that when you start getting into meal sizes that start exceeding that 6 to 7 pounds of dry matter or 3 to 4 kilograms, you start to see some dramatic changes in rumen pH, and of course that is going to have some behavioral patterns and certainly some digestibility factors as well. So while this is a fairly short module, it's a very exciting one because it says cow behavior really impacts on how the rumen functions, what kind of dry matter intakes we can expect, and what a factor such as age can have on the animal. Well, thanks and have a good day.